Hello friends! Today I'll be taking a look at this new power supply made exclusively for the Macintosh SE and SE30 computers, released this summer by Chris of Babyface Electronics. It's sold on eBay under Chris's Circuits Electric vendor name, and I've put a link for you to that product page in the video description below. I'll be comparing it to the SEASONIC power supply that I installed way back in November of 2018. I'll also be comparing it to the stock SONY power supply, which is the more highly regarded of the three power supplies which Apple originally used for the SE and SE30, the other two being the Aztec and the Hitachi. So let's get started. As we can see from this chart, both the SEASONIC and Babyface units provide more current than the three power supply models Apple used. The SEASONIC offers the highest amperage output for the +5 and +12 volt lines, but the Babyface PSU still offers a very respectable 10 amps and 5 amps output. Like the stock SONY power supply, the Babyface power supply is also convection cooled, and that just means that whenever it operates, it doesn't make any noise at all. However, the SEASONIC power supply is different. You'll notice over here, this little black gizmo is a fan. It's temperature controlled fan, and although it's not very loud, it's still noticeable, especially if you're someone who has swapped out your spinning platter hard drive, which is fairly loud, with a modern solution like a Mac SD, a Blue SCSI, Zulu SCSI, or something like that. And if you've also swapped out your analog board case fan with a nice quiet Noctua like mine, then your ears are more accustomed to quiet and you would notice this fan noise a bit more easily. Again, it's not that loud, but it is something that you'll notice, unlike the Babyface, which has no fan at all. If you check the text description down below, you will find a very detailed Google spreadsheet that I made for you showing all of my voltage and wattage measurements. And in that spreadsheet, you'll see my testing process started out with a very basic rig, very minimal RAM, and no upgrades. And I slowly worked up to the maximum rig, maxed out rig configuration that you see here today. Now, this is not the only maxed out rig. You could max out your SE30 in other ways, such as with a Daystar Turbo 40 accelerator. I have one of those, but I decided to go with this because this draws a comparable amount of current, and I cannot, the Daystar Turbo 40 is not compatible with the Micron Xceed setup. So for me, this is a maxed out configuration. For you, it might be something else, but even if yours is a little bit different, this draws a lot of power, so it's really something that you can go by to determine, hey, is this power supply up to snuff or not? And I know that my SEASONIC is because, again, I've been using it for a number of years now, but this video is going to show you how well that the Babyface responds to the added current draw. Specifically, going through all of the upgrades, I have 128 megabytes of RAM, 16 megabyte SIMs in all of the RAM slots. That's the maximum you can put in. I also have a modified ROM SIMM from Kero, 2 megabytes. It has an LED on it. It draws a little bit more current than your average ROM SIMM would. I also have a socketed 50 megahertz 68030 PowerCache with 50 megahertz FPU accelerator board installed on the motherboard. Socketed means it's in the CPU socket. And that draws a fair amount of power on its own. And then I have the Micron Xceed MacroColor 30HR video card, the top end card over here in the PDS slot. And I also have the highly coveted Grayscale Adapter yoke board here on the back of the yoke, which includes a customized harness. So the wire harness that you see in there is for the Xceed kit. And I mention the harness to say that when you go through the numbers in my spreadsheet, you will see that when I started off the base configurations, going up all the way until I installed the PowerCache, I used this, which is a slightly upgraded, otherwise stock harness, which this is called your main wiring harness. It goes between your analog board and your motherboard. And I upgraded it by soldering on fairly thick 18 gauge wire on each of the two +5 volt wires, thereby reducing the resistance of each, which helps boost the voltage measured at the motherboard. And in addition to that, the connectors were a little bit green, which means they were oxidized, and so to remove that, I sprayed on my highly regarded contact cleaner, Deoxit D5. And this is really good stuff because this is not only a cleaner of the contacts, but it also is a protector. It leaves a little film on there so that over time your connections are not going to oxidize once again. And it's kind of expensive, but really great stuff, so I use it quite often. And when you apply it properly, then what happens is you will put it on the connector, and then you need to connect this harness to the analog board and motherboard connectors by connecting them and disconnecting multiple times, and that puts the deoxit cleaner on the mating connectors. So they also get deoxidized, and the protective film also applies to them as well. And all of this means that I really optimized this harness to make sure that I'm not going to get an unusual voltage drop because of a bad connection or aging wires. Aging wires and the connectors are really the main reason that you would get a higher than normal voltage drop. But even though I did all of that, once I installed my 50 megahertz PowerCache, I was getting a voltage drop that was more than expected. And I measured that using, this is my KMac Vintage Macometer, and this is really neat. You should see my video on it if you haven't already. I think every compact Mac owner should have one of these because it's convenient, very accurate, and safe to use too. You just plug it into the external floppy drive connector in the back, and it gives you the 5 volt and plus 12 volt line voltages. And so the voltage I'm talking about, the voltage drop, is usually measured with this one. And I was getting 4.79 volts, which is, you know, it should be 5, but I was getting 4.79, and it's enough to run the system. And it's something I've seen in the past too. But, well, even with an optimized harness, or near optimized, truly optimized would be brand new wires, brand new connectors and all that. I didn't go that far, but I did the next best thing and upgraded it. Even with this upgraded cable, I was still getting 4.79 volts. And then, of course, when I installed my Xceed kit, it comes with its own harness, so I had to remove this one and put in this harness. And I did not modify this harness in the same way. So I got an even lower voltage after I installed that. And in part because the Xceed kit draws 6 watts additional, but also because I didn't beef up the harness in any way. It was still enough voltage to run the rig, and you'll see that later. But I just want to say that you're watching this video today to see if you should buy this or not, or possibly the SEASONIC or something else. And the answer is yes, having a new power supply is good, but if you buy one and then you get lower voltage than expected and your computer doesn't work right, or maybe it doesn't even boot at all, probably it's the main harness. Either this harness, or if you have an Xceed kit like I do, it could be that one. You need to make sure that you use your contact cleaner. If you need to beef up the wires, you need to do that. But also, if there are any connections like solder joints that are bad, you should resolder those to make sure everything's good. Recap your whole system before you change out the power supply. Otherwise, you're not going to know if the problem is from the power supply or something else. But even with all of that, mine is fully recapped, all the joints resoldered and all that. I'm still getting some voltage drops, and you'll see that when you go through my spreadsheets. So now I am going to do the installation of the babyface power supply inside my SONY metal chassis. And it could be, you need to check, but it could be that you have an Aztec or a Hitachi and not the SONY. And that means that your metal chassis is going to be a little bit different on the inside. And if you do, you just need to watch Chris's video, which is quite good actually, which covers the installation of his power supply in the Hitachi and the Aztec. And after that, the rest of my video will apply to you because, well, it's the same guts, right? It's just a slightly different metal chassis. And so what I'm showing you here, the installation that I'm about to show you, is for this SONY metal chassis. For those of you who already know how to discharge the CRT and how to remove the analog board and the power supply, you can safely jump to the next section. For the rest of you, let's proceed. What we're going to do now, before we touch anything else, we want to just mention that the main power cord is connected to our power supply, but the power switch is off. So this is a grounded cable. We were grounded to earth ground. And this is switched off. That's very important. Next, we're going to use a cable with alligator clips at both ends. These clips are larger than your standard alligator clip cable, and the reason why is because the standard clips don't fit very well around a negative-minus screwdriver flathead, and this one does. So one end is connecting to the metal, and of course you need an insulated handle driver like I have here, and then the other end is connected to the upper left corner of your CRT, which is called the ground lug. This is where the main wire from your yoke board comes and connects. And you could technically ground it here only if you disconnect the motherboard. And this is recommended by Apple. It's saying that if you want to not worry about disconnecting the motherboard, use the ground lug. And that's what I always do. If you disconnect the motherboard, you could technically ground anywhere along the metal chassis. But I recommend you don't do that, just because it's good to get in the habit. Whether it's disconnected or not, use the ground lug. Okay, so it's connected there. We have it here. I'm going to use a fingernail and pull back this suction cup. No, you're not going to get any shock or anything like that. Chances are the bleeder resistor has already discharged it, but we're doing this just in case, right? Just in case the bleeder resistor didn't do its job. And you know, you don't use common sense. You don't want to grab this copper area with your hand. That's where the high voltage is. And you know, you don't want to touch any exposed solder joints on this yoke board or anything like that. And we're just going to take a finger and, you know, pull it back a little bit, and so that I can slip in the head here, and I'm going to push down. No spark, no sound. The bleeder resistor has done its job. And then I'm going to push down, because that'll bend these little guys that are in the inside, these little clips here, and allow me to take it right off. So now it's discharged. Next, I'm going to remove the analog board so I can get the power supply out, and I'm going to start with this little ground wire down here. Now, if you're wondering what this green pad is, this is a anti-static mat I've got connected by wire to the earth ground, and I've also got myself grounded here too, to the same earth ground. There's a couple chips on the board here, and I know that many of you have handled these without any anti-static precautions, but it's still a good idea when you have the ability to ground yourself so you don't accidentally zap anything. So we're going to go ahead and remove this screw down here. Now I'm going to remove the screws on the solder side of the analog board, specifically these two down here and these two over here. And then these two screws and these two screws are for the power supply. By the way, I removed the vinyl sheet, which normally fits over here. You don't have to remove the sheet. You can access all of the screws with it in place. The main reason I removed it is because I'm making voltage measurements here, and it's nice to have it off. You can remove yours by removing little black rivets, and most often you can just push them out from the other side of the board with your finger, but you can use a little flathead screwdriver to push them out as well. And since the screws are not all the same, I bagged them up separately. I now need to disconnect the connectors to get it all separated, and the easiest one is this one up here. You can see that I've elongated it because I had to replace the connector. This was burned in the past, so I replaced both. And I'm going to carefully remove the yoke board because it's in my way. And that will allow me access into this area. You can see there are three connectors in here, the rightmost being the hard drive power. Now when you're pulling, you want to make sure that you don't hit the neck of the CRT, right? If you break that, you're going to have a very bad day. So you don't want to do that. Just be very careful, pull out very slowly. Two of these have push tabs. Okay, that's the Xceed harness, and I can get the hard drive out of the way there. And then we have this connector here, which goes to our power supply. Now we want to carefully get the analog board out, but keep in mind down here, deep in this hole, you've got the brightness knob, so you want to be most careful about that, not to just yank it out and bend that knob. So you'll have to take your hand and hold on, power supply there, and slowly and carefully pull him out and make sure that your little wire here is not going to yank on that yoke board, and there he goes. And we can just pull the power supply right out. Now begins the power supply disassembly, requiring me to remove these two heatsink screws. This entire plate actually will act as the heatsink, as we shall soon see. We don't need to remove this screw over here. We can just leave the screw and the wire connected. And now to slide this plate off, I need to remove the two screws up top. And then with your fingernail, or in my case, a flathead screwdriver, we can just slowly pry out the plate. And then we can slide the plate this way because there's 2 feet on hooks down here. We got it off. Next, we'll need to remove this screw here on the side. This is also a heatsink screw to a small component. And we remove the screw and the heatsink clip as well. Now, if you peer down inside at the motherboard, you can see there's a screw here, here, and here. So we need to remove those. Then we can take off this thermal pad. We then want to disconnect the little connector down here. And there's some glue that was holding it down, but it's easy to break off. To remove this harness, we need to remove the holder just by pushing down on the tab in this rectangular slit, which lets us pull it right out. And then we can remove the entire circuit board. And we're going to have to pull it up out of this way so we don't get it hooked on these 2 hooks here. And there we go. Now, even though Chris includes this nifty little connector with the babyface PSU, we can't use it for the SONY power supply chassis. We're going to have to desolder our stock connector from the SONY PCB and use that in the babyface. So what I've done to make that easy, you all probably don't have an FR301 Hako like I do. This is a desoldering gun, but I have a 1.6 millimeter tip, and that should be wide enough to desolder these rather thick pins from the other side. Okay, here we go. And it comes right out. Be sure to use pliers and not your fingers, it's pretty hot. And here's our babyface PSU. You'll note there's a connector set of pads over here and a separate set of pads over here, but this is the only one that says SONY. So this is the one we want to use. This says Singapore Aztec, which is not what you want to use. And by the way, this is the connector that Chris includes, which has this plastic backing on it. And if you try to put it in here, it won't fit. The pin spacing isn't wide enough. And because there's 3 pins and they're not all spaced equally, you can only put it in one way. So you see, that connector that Chris includes goes here. And you are not going to solder it in because you're not going to use it in the SONY chassis. And this connector that we just desoldered is one that if we try to put it in over here, it doesn't fit either, right? But then if we put it in over here, it fits like a glove. So that's the location that you want to solder the SONY connector. It's going to fall out unless you secure it somehow, and everybody's going to be different, but I have this aluminum flashlight that dissipates heat pretty good, so I'm not going to keep the soldering on there very long, so it's not going to harm my flashlight. Anyway, you don't want to touch it with your finger. You don't want to put foam or something that is going to melt, because these pins are going to get hot while you solder them. Now technically you don't need flux, but flux always makes your life easier, so I'm going to put just a little dab on there, and then it'll flow more beautifully. I'm using my ultra thin solder today because I ran out of the thick stuff. This is my 0.6 millimeter. If you can use thicker solder, it's going to work a lot better. And it's soldered in nice and straight, as you can see. Here's some points of interest before we slide it in. You want to get your wires moved out of the way to the far left, and you're going to need to take note of these two protrusions here. You don't want to slam your PCB and scrape it against them. And also there's these little offsets, standoffs. They're raised here, here, and here. That's where our 3 screws went in. And then we have over here a couple protrusions. There's 2 of them, and we want to slide the circuit board in between the 2. So we're going to have it moved over a little bit to the left, and then we put it down and then slide it in. And actually I see my, there's a heatsink pad, a thermal pad here. We don't need this, so I'll go ahead and remove it. So here's our power supply, and I will put him down in here that way. And then stick him into those 2 protrusions over there on the right. And there we go. So I will now unbag the 3 screws. I like using bags. Keeps everything nice and tidy. And I'm not securing it tightly. I'm keeping it loose, because you can see Chris, he didn't make circular holes, he made ovals. So that way you can have a little flexibility in mounting it. And now we can secure our connector. And before we can put on the top plate, you want to make sure it's not sitting like this, but it's at an angle. Otherwise the top plate will press hard and cause problems. I might need to remove that glue. I'll see here in a minute. And then before we can put down the top plate, we need to put in our little rubber grommet. And then when the plate comes, it will press down on the grommet and make it more into an oval shape. And there's still enough leeway to pull any excess wires. I cut off the excess glue to make it lay down a little bit lower. So now we need to put in these 2 hooks first. And then we push down so that these 2 tabs sit underneath the top metal, not on top of the metal. So this part isn't pressing against anything. This part's coming up only because of the grommet, so we're okay. Of course, we're not going to put screws in here now, right? There's nothing for them to screw into, so we're only going to put the screws back up at top.
And there we go. It's a nice little oval shape. It's not too tight. It's just right. And just to show you, you can see the circuit board fits perfectly in between those two pieces of metal. So this is your final check, you know, just to make sure you didn't put the circuit board on top, but it needs to be in between those two strips of metal there. So before putting the power supply back into the SE30, I'm going to do what's called a no-load test, and that means we don't have anything connected to our main power connector at all, other than our multimeter, and I have my EEV Blog 121 GW meter here set to measure DC voltage, and I've also got my watt meter here, which can measure more than just watts. And all of this data you're going to find in my Google spreadsheet, so be sure to check that for the details. But if we go over here and check the 5-volt line, ground is already connected, so I'm just going to touch where the 5 volt is. We're getting 5.037, so I'm just going to take 2 digits, so about 5.04 volts. And by the way, this has been connected for 5.5 hours or so, and I've just left it on to see if it would warm up, and it's very cool to the touch, and not surprising because look, it's been drawing 0.1 watts, which is by far the lowest. I've also compared with my SONY, Recap SONY, and the SEASONIC, and I must say that it's a huge difference. I mean, this one draws the least amount of power when disconnected of the bunch, and if we compare with the SONY, 2.6 watts. That the SONY draws continuously with nothing connected to its connector at all. But you know what? The SEASONIC is even worse because the SEASONIC draws 5.1 watts when nothing is connected, and it gets warm to the touch, and even its fan will kick on with nothing connected at all. Now the SEASONIC is an otherwise good power supply, but it's just going to show that not all power supplies are created equal when nothing is connected. Okay, so now we've checked the 5-volt line. Let's check the 12-volt line. It's 12.135, so 12.14 volts. Now normally you're going to have on the stock supply and even on the SEASONIC, you're going to have 2 plus 12-volt lines that are separated. And on this particular power supply, that is not the case. The two 12-volt outputs are connected to each other. So normally on this top left pin, that would be 12 volt for sweep circuitry for the CRT, and then the one below that is going to be a separate plus 12, just normal 12 volts for like the drives and such. But on this power supply, they are connected to each other. So you see 12.135, and then we go up here, 12.135. So they are the same. But this is a very stable power supply. So Chris had mentioned this online when he was discussing it, but basically you need a very tightly regulated supply, and then it should be okay to have a single 12-volt output. So we check the 12 volts, plus 12, and plus 5. And now we're going to check the minus 12, which is over here. And we're getting rock solid, I mean, 11.997 is basically 12.00, right? So we're getting a rock solid minus 12 right there. And then the rest are grounds. So again, I just want to emphasize very low, 0.1 watts in standby, which means it's no load. And then we go over here and we see this is Japan. So it's a little bit lower than the US. We get exactly 100 volts, 100.2 right now, AC. And this is the number of milliamps, or amps in this case, 0.039 amps, or 39 milliamps is how much current it's drawing. So it's not absolute zero, but it's extremely low. And then if I go over here, we can see 60 hertz. In Japan, you've got 50 hertz and 60 hertz areas, but where I live, it's 60 hertz, same as the USA. And then the power factor down there, 0.02. The power factor doesn't really have a lot of meaning in this case, but again, all of these numbers for all the 3 different power supplies, check my Excel file to see them. So now that we've done the no load test, we can move on to reinstalling it back in the SE30. Now we're ready to put it back in. Take note, your brightness knob slot is here. And if you don't fit it in correctly, then it's going to be hard to turn. So before you screw down everything, we're going to do the brightness knob check to make sure that's okay. Some people prefer to mount the power supply with screws to the analog board first, but I personally find it more difficult to put it in that way. I think it's a lot easier to just put in the power supply first, like this, move it over a little bit, like so, and then we can take our analog board, see very clearly where to put in the brightness knob. And the trick here is to make sure you've got the bottom of your board. There's two slots in the PCB that fit over these two little hooks down there. And now it's sitting on the hooks. And then you want to make sure that the board fits into this top and middle plastic area. They're little grippers. So make sure it goes in there. And then you want to eye it to make sure your holes are lined up right. And then we can move our power supply back like so. Now before we screw anything down, we want to have the ability to move this around. First of all, very carefully take your suction cup out. Lay it like this because we're going to have to make connections here. And the shortest wire is your power supply cable. And it's kind of short like the original was. And so I'm going to dislodge the analog board. And you don't want to yank on it, but we want to fit that in, right? And it snaps into place like so. And then we can put in our connector, one up here. It's keyed, it only goes in one way. And then we've got our Xceed, in this case it's an Xceed wire harness. Probably you don't have this, you're going to have the stock wire harness, but you would want to put in your main wire harnesses connectors right now. And don't forget your hard drive connector. If you're using a regular hard drive, you're going to need that. And that connector is kind of deep down in there. But again, with the analog board free, you can move it around and get him in. And that looks like we got everything. So now we'll do the brightness knob. It's a little bit hard. Okay, now it's moving freely. So yeah, it's not, it was rocked back a little bit, but it's in there. So basically we need to do these two screws to mount it in there. And we want to, you don't want to forget your little plate here when you put it back in. And now we'll do the power supply screws, which are a little bit harder because the power supply needs to be properly aligned. Putting in these screws will be easier than this one because there's more distance. There's more of a gap over there. So let's put these in first, whichever. Now, I am putting my hand on the opposite side, the inner side of the power supply, and pushing towards the PCB on it, especially because those are brand new wires, they're very stiff. So I'm pushing it towards the PCB. If you don't do that, your screw won't reach it. And just to let you know, the reason why I didn't put on the vinyl sheet is because I'm going to make voltage measurements here, and I can't do that if the vinyl sheet is back on. So in your case, you're not going to make any voltage measurements, most likely. So you'd want to make sure you put your vinyl sheet back on, assuming you took it off, before you put it down. It's a lot easier to put it on that way. Also, do not forget to put on your ground. And if you have a Micron Xceed video card like I do, you're also going to have its ground too. If you don't, then you're only going to have the one, but it needs to be secured. So you'll need to figure out how to put both of them on there. Okay, nice and tight. And now I'm going to connect this to the main motherboard, but this cable is in my way. You can disconnect it at the motherboard or your hard drive, whichever. And so now we can see the motherboard cable. Even then it's going to be a little bit of a trouble to get in there. Sometimes you can pull your motherboard out a little bit if you need to get it away from that drive sled. A little bit more distance there, but I think I got him in there. Yeah, it's in there now. So now I put back my ribbon cable to my hard drive. SCSI cable here. Okay, then I've got a cable that goes into my MacroColor 30HR card. And then, being very careful, I should connect my connector first to the yoke board. Then carefully slide him on. And last but not least, we've got our suction cup. We've got two hooks here, so put the bottom one in first. Pull it back. It's discharge, you don't need to worry about any high voltages. And we're going to take our flathead and then push down on the top one so it slides in. Twist it a little bit. And there it is. All finished. Now it's time for the smoke test. I've got my keyboard and mouse connected. That's just a normal operating condition. That's going to pull some current too, so it has meaning to keep them connected. My macrometer is attached to the external floppy drive port. I've got my watt meter hooked up. The surge suppressor I have here is powered on, so all that is left is just to flip the power on here. 3, 2, 1. You got a bong. Getting a bit low, 4.6, 4.5 volts there. Okay, I'm seeing some artifacts there on the screen I've never seen before. Seems to be gone now. I could hear a little sound in the area of the vicinity of the flyback, like there was some kind of switching high frequency noise, but the artifacts seem to be cleaned up okay. Probably the best way to test would be run a benchmark. So we'll use SCSI Director and test. And it's testing the drive. You can hear it too. Butterfly really pounds it. But I am not seeing any kind of noise on the screen. What I should probably do is run a longer benchmark. System Info is a pretty good benchmark utility. It'll also test the drive, but it will test other things too, including CPU, display, and so on. And it's showing here my MacroColor 30HR is installed. 50 megahertz 608030, so it's recognizing the PowerCache. It's recognizing the FPU. It's showing I've got my spinning platter hard drive, so we'll go ahead and run this. Well, it passed all the tests, and I didn't see any artifacting on the screen at all. So it looks like I can't really explain the initial artifacting that we got. Okay, current system. Oh, you saw the hiccup there. Okay, so now I'm going to take a voltage measurement on my scope at the analog board, the plus 12 volt sweep, which is technically the same as plus 12 because of the babyface power supply, but right now the power to the SE30 is off, but I'm going to switch it on, and then we'll be able to see if the 12 volt line droops or otherwise has noise on it in comparison to what we see on the screen. So, ready, go. And we are seeing noise, a lot of it. Look at all that noise. And then it gets cleaned up. Freeze it right there. And of course it droops down when I remove the scope. So we're getting a huge amount of noise on the 12-volt line there. So if we measure this peak to peak, this is not RMS, but peak to peak, the very most extremities, we see delta Y is showing us it's 17.3 volts. Remember, this is a 12-volt output. So we're getting higher peak-to-peak noise riding atop this 12-volt output than we are the actual 12-volt output. This is a pretty serious amount of noise here. And if we zoom in on it, it's just appearing to be random spike noise, spiking up and down. So the actual width of our spike, just in one case, is about 1 microsecond. And this is the scope probe. So as you can see, the ground wire is extremely short to minimize any noise that would otherwise be induced by way of a long ground wire. And so the noise that you're seeing on the scope really is the noise that is being generated on the board during cold boot. And for my next test, I decided to remove my Micron Xceed video card and Grayscale setup. And as you can see here, I have no PDS card installed at all now. I have the stock yoke adapter and ground cable connected. And I have the stock wiring harness modified by me to add an additional thick wire on both of the 5-volt lines. And we're going to see how the babyface PSU responds to this. Okay, I'm now going to power on. Here we go. Screen's beautiful. No problems. No high frequency noise. It's booting from my hard drive fine. In this configuration, I'm getting 4.87 volts on my macrometer. And this has an accelerator in it. It's the 50 megahertz PowerCache. It just doesn't have anything in the PDS slot. And to satisfy my curiosity how the plus 12 volt sweep will look on the scope in this configuration without Micron Xceed, I'm going to switch on the power now so we can take a look. We're getting a nice waveform. No surprises, right? Rock solid screen, because we're getting a rock solid 12 volts at the sweep. Okay, I'm now back again with yet another test. I have swapped out the power supply for the SEASONIC, the one I've used since 2018. Never had a problem with this Grayscale setup at all. And I'm measuring at the sweep, at the analog board, just like before. And this will be the first power on after putting everything back together. No noise on the waveform or on the screen. I mean, you got a little bit of noise, but we're talking a satisfactory amount of noise relative to what we got with the babyface in this configuration. This configuration being, again, the Micron Xceed 30HR, MacroColor 30HR video card in the PDS slot with the Grayscale adapter on the yoke board, and of course the harness that comes with it. And if I check macrometer in the back, we're getting 4.65 volts, so that's a bit low, but still we're getting enough to boot the machine here. And we need to draw some conclusions from this. And just to let you know, I zoomed in on the noise that's riding on top of the plus 12 volt sweep, and this is just approximate. It's not RMS, it's just approximately where the maximum peak and lower peaks are, and our delta Y says 1.39 volts. That's a lot, you know, on a 12 volt signal here, but this is considerably less than, what was it, 17 volts that we had with the Babyface in this configuration. But for whatever reason, when we take out the Micron Xceed Grayscale setup, it's not a problem for the Babyface. And just so you know where I was using my scope, this is the power switch over here. And I was putting the scope's little ground point on this screw, because this is ground. And then right next to it there is 12 volt sweep. You can see that the trace comes around over here. And yeah, I could have measured it over here, but it's really convenient for my scope because I used a really short ground probe, ground pin there. And so it made it nice for me to measure right there. So what I did is I spoke to Chris about the problem, and Chris gave me various possibilities to mitigate it. And I decided that the one he was really pushing, it would delay my video to do that. And he wanted me to buy another 12 volt module. He would compensate me, of course, but I have to ship it from the US side and get it over here and then desolder and then resolder it in and solder in the new module and test it. It just would take too much time. And on top of that, I don't think it's really going to tell us much. That's my personal opinion. I think Chris has a different opinion on it. But if I test it and it works, what is that really telling us, right? Because this 12 volt module in here right now works perfectly when I take out the Xceed kit. I don't really call that a defect, right? In my opinion, that's not necessarily a defect. It could just be a tolerance among modules. And what is that tolerance? We don't know. And if it doesn't work, that doesn't really tell us much either. So that's a test that needs to be done, and I believe that Chris would probably want that to be tested at some point. But for the sake of this video, I decided not to do that, and he instead said, okay, there's something else you could try. You can add capacitance. So what I did is I pulled up the schematic for the analog circuitry where a 12 volt sweep comes in, and it goes to a chip called TDA 1170N. And so what I did is I pulled up the schematic for the not schematic, but the data sheet for that chip. You've probably seen it before. It's got these little wing style heat sinks on it. It's a low noise TV vertical deflection system chip. And it also has a example application circuit for a small screen TV set, which is not too dissimilar from what we have on the Mac. And when I looked at the circuitry, I said, well, it's 100 microfarad capacitor, diode, 0.1 microfarad capacitor on the same pins. All this circuitry is the same as the Apple schematic for the analog board. The only difference is this application circuit has 470 microfarads of capacitance right on that sweep. Yes, it's 26 volts in this example, but that doesn't matter. They put a 470 microfarad capacitor right there. And so I decided to solder on a 470 microfarad capacitor because Chris gave me a range of values that I could possibly test, and this was the upper end of that value range. And this is 50 volts, nothing magical about that, but that's a capacitor I had on hand, it's new, and I soldered it in at the sweep and ground right where the power supply connects to the analog board. So not too dissimilar from connecting this power supply inside the power supply itself. And I've been testing off camera, and so far, I haven't found the noise come back. It's completely resolved the problem. Some of you who have already purchased this power supply said, oh my goodness, what about me? Well, I don't believe any of you have had this problem because I asked Chris, have you received any reports of people having a problem similar to mine? He said, no, not even one. Plus, Zigzag Joe, member on for Tinker Different, 68K MLA, he's a genius in creating some clones of old technology, and he has tested a similar setup with an Xceed board like mine. I don't know if he's using a quantum hard drive like mine. Maybe it was a Blue SCSI. I don't know. He couldn't find the problem. So I am the lone man on planet Earth again who has found this sort of thing. But it's good because I kind of figured this setup might find some problem if there was a problem, and it did. And so even though Zigzag Joe and not a single one of you who have purchased this power supply already have had this problem, the fact is I did, and the fact is the adding of this capacitance resolves the problem. So even if you've already purchased it, I don't think there's anything to worry about. But Chris did say he would possibly add a capacitance in a future revision of his power supply just to make sure that nobody else encounters the same type of noise problem on screen like I did. I'm now going to flip on power so you can see the screen for yourself. Comes up perfect. No noise whatsoever. No strange sounds in the vicinity of the flyback either. And this is the condition under which I did my voltage measurements that you're going to find in my Excel file. Just a regular default gray screen and no windows open, just like this. I left the machine running for at least 15 minutes. Usually you want to keep the machine on for at least 5 minutes before you start measuring, but I found that 15 minutes makes it pretty stable, although I've done measurements at 30 minutes and 1 hour just to compare, and there are some differences, so you're going to see differences over time for voltage measurements and watt measurements, but I just want to point out, this is also written in the Excel file. This is the condition. I'm not running any benchmarks or anything at the same time I'm doing the voltage measurements. It's just basically the machine at idle. As mentioned in the Excel file, the way I measure the 5-volt line is at the motherboard at the external floppy drive connector using a macrometer. There are other ways to do it, but this is really the safest way, so I would recommend, if you want to make voltage measurements, and you should actually, to get yourself a macrometer. By the way, this is the highest voltage I've seen out of multiple tests in measuring voltage, and the lowest I've seen is 4.50, and that was after doing some benchmarking. And after doing the benchmarking, it then came back up to about 4.62, and that's what I put in my Excel file, but it can vary, and usually 4.5 volts is as low as it can go, and then it's going to power down and then usually cycle on and off, powering up and down because it doesn't have enough voltage. So that is one issue of concern with this babyface power supply, is that its no load voltage is the lowest among the 3 power supplies, the SONY and the SEASONIC. And so that is going to result in lower voltages, comparatively speaking, than the other 2 power supplies. And the way I measure voltages at the hard drive connector is using my 121 GW with these Probe Master extension leads. See my review of the Probe Master kit for more information about that. And that allows me to, you still have to be very careful, but I can put one of the probes on ground and then another one over here, and then we can see we're getting 4.98 volts. And then I can put the other probe, I can put the probe, switch it to 12 volt side, and we see we're getting 12.11. You have to be careful, you don't want to accidentally touch your, you've got high voltage there. So you really do have to be careful. I'm just showing you the way I tested it, so don't necessarily follow me unless you're extremely experienced at it, because the machine is on and powered and you've got high voltage here. So then what I do is I take my little safety tips here and I can slide them on so that just like a millimeter or 2 of the tips come out, so you don't have a long probe tip that would accidentally short. And I'm not suggesting you do this, but the way I made my measurements at the PDS slot is I just tap ground on the chassis ground here. You could also tap it on the pin, but it's a little bit more precarious to do that. And then the way I know what to tap is given, I've got a little printout that tells me minus 12 is at the bottom, minus 5 is in the middle, plus 12 is at the top, and then go 4 over and you get plus 5 volts for all 3. And so then I can just tap the top one. You can see it's plus 12.096, and then go to the next one. We're getting minus 5.03, and then you can keep going from there. So that's how I got the PDS measurements. My final set of measurements check the noise riding on top of the plus 5, plus 12, minus 5, and minus 12 volt lines at the solder side of the main wiring harness connector right here. To make the most accurate measurements possible, I switched my oscilloscope's probe to the 1x setting with this slider switch, and I also switched my oscilloscope to detect 1x since the oscilloscope doesn't automatically detect the changes made to the slider switch. I also set my scope to AC coupling to eliminate the DC offset, and because the ground lead on scope probes act as an antenna to pick up noise, I used a very short lead. Now I'll go ahead and clear this off so we can take our measurement. And this section of the pins, they're all ground. From here all the way over to here, it's all ground. So I can stick my ground pin on one of those pins, and then the next one over, next from the ground, is going to be minus 5 volts. So I'm not going to take all the measurements here on camera. You can see my Excel file for that, but I'm just showing you how I'm actually taking the data, and I'm pressing hard against the ground pin and pressing hard against minus 5. And then I let go and stop it from there. And then I've got my cursors, and I can get an approximate reading. This isn't RMS, but it's just approximately where the peaks are at top and bottom. And it's saying delta Y, for this measurement anyway, is about 31.2 millivolts. And so then I repeat that measurement for the minus 12, which is the next one over on the bottom, and then up we've got plus 5 and then plus 12. And just to let you know, this 470 microfarad capacitor isn't going to stay permanently soldered here because I can't put the case back on with it soldered here. But all of the measurements in my Excel file were done with this capacitor because this capacitor is what eliminates the noise on my CRT with my Xceed Grayscale setup. And Chris said he would eventually put this into a future revision, so I think it had merit for me to leave it soldered on while I made my measurements. Halfway through the filming of this video, I learned something new and quite shocking. You'd never know by looking, but these two main wiring harnesses have the exact same 22 gauge wire inside. This one on the left is used by the Macintosh 128K and has thin insulation, making the wires look about as thin as they really are, but the SE30 hides the truth with thick wire insulation. Even Larry Pina was wrong in his Macintosh Repair and Upgrade Secrets book when he wrote, Mac SE harnesses are 18 gauge. That's wrong. Zigzag Joe was the first to mention this in February 2024, and much to my surprise, he found pre-crimped 16 gauge wires of the exact length needed at DigiKey. I ordered several, so now I can show you how to upgrade your cable. Now, because I don't have a special Molex tool to get these wires out, what I use is a number 3, at least here in Japan. These are a little bit thicker than normal staples, and I just break off a couple staples. And what we want to do is take some cutters, and we just cut off one end to make it into an L shape like this. And we just do the same with the other one. Let's cut off one end, and then we have 2 L-shaped pieces. This will be our removal tools. Well, joy of joys, I just filmed the removal of this one, and I found that my mic was turned off. So, rather than put it back in and take him out again, for your sakes, I'm just going to proceed with the next wire. Which is, both of these are marked 5 volts up here, and yours will only be orange because you're going to have a factory harness, and I have a blue one that's soldered onto the other one. And so what we want to do is, we want to take our tool, the long end of it, and we want to stick it in on the right side of the terminal that we want to remove. We're not going to stick it in the hole of the terminal. We want to stick it to the right side. So it's kind of wedged in between the right side of the middle terminal and the right side of the plastic edge of the hole there. So we want to push it in as far as it'll go. And then we take our other tool and we're going to do exactly the same. And that one's going to be a little bit harder to put in. And that's why we want to use thicker than normal staples, because you need a little bit extra strength so that they don't bend. And that's why I'm choosing these number 3 staples here. It's pretty hard to get in there. You might have to push it down on a table, but what I try to do is push the wire in this way a little bit, so then I can make sure I get that little wing inside. No, I didn't get him. And so sometimes you got to move it around a little bit and try again, or maybe take a tool. But you don't want to bend it. Ah, there, okay. I got him in, I think. Let's see. Yep, I got it out. And it's not really that difficult, so long as you can get both of your tools onto either side, and you're pushing those wings towards the body, which allows it to be able to pull out. And so now that I've done the two 5-volt wires, I'm going to replace these with 16 gauge. I want to replace 3 of the grounds. Now I'm not going to replace the 2 grounds that are already twisted. So if we look at which ones those are, we've got these 2 grounds here are twisted. So this ground, the black wire here, is not twisted with anything. I can replace him. Then there's a ground over here, not twisted with anything. I can replace him. And then there's a ground here to the far left that I can replace. And I'll go ahead and do that. And now that I have both ends of my 2 5-volt wires and one of the grounds out, I'll take my 16 gauge replacement wire and put it in this hole. Now you have to remember which way to put it in. You don't want to put it in the wrong way. So to see that, okay, so we want to have it like this so that this part is facing up. I'll put it in this slot, and it's in there now. And then I'll take one of my 16 gauge replacement grounds. Since I removed the ground from over here, I'll put it in here. And even though I don't have to, I'm going to twist them because these wires are longer, right? They're longer than the stock wires. So to make them shorter and not be so awkward, I am going to twist these 2 wires, and actually it will help with noise immunity if I do that. Twist them and then reconnect them over here. And then you want to make sure you get your crimping in the same direction. So I'm gonna, it's not the closest one to the yellow, but it's the one farthest away. We got that one in. Then we got our ground in there. Still a little bit long, but not too bad. And we'll do the same with another red and another black wire. I'll put in my black wire and the red. Now we can see we've got the 2 twisted red and blacks, and then I'll just do one more black to finish it off. And this is the end result. I ended up taking that last ground wire and wrapping it around the +12, just to improve the noise immunity, but mainly to reduce the length of the wires. And I could have done more, but I felt that replacing 3 of the ground wires and both 5 volts would be more than adequate. But you can take it to the limit and replace all of them if you like. Just keep in mind there are only 2 colors available that are pre-crimped at the right length. And we can do the same for the Micron Xceed wiring harness too. And after putting the harnesses to the test, here are the before-after numbers. Now I know you want to know how hot each of the power supplies get, but it's really hard to measure that in a consistent, meaningful way. I need to do it with the plastic case back off, but that has an impact on internal temperatures. And I can't take off the side metal plate of the power supply because the SONY uses this as its heatsink, but the Babyface and SEASONIC don't. So what I did was just point my UTI thermal camera, this is the UTI 260B, and I just pointed it and looked for the hottest parts of the computer. Now I just switched this on, so it hasn't reached its maximum heat yet, but the hottest part that I measured is this diode up here. That's heatsink and connected to the flyback cage. And right now it's only measuring about 79.5 degrees, but when it's on for a while, it will heat up to between 83 and 86 degrees, which is pretty hot. And the second hottest thing I measured was the SONY power supply, which reached about 75 degrees on the inside, as measured through a little hole on the back. That's all I could access, the inside guts, with it all being assembled. And after that were the visible chips that are a part of the PowerCache, and that's not even the FPU or CPU, and they were reaching between 61 and 64 degrees Celsius. And one chip on the hard disk was really getting pretty hot. It was about 62 degrees Celsius. The big resistors on the yoke board of the Xceed Grayscale setup, those hit about 60 degrees Celsius. And the highest temperatures that I could measure on the SEASONIC, externally measuring it, was about 46 degrees Celsius, and that's with its fan running. And on the Babyface, I measured 51 degrees. Again, externally measuring with my thermometer, 51 degrees Celsius, but keep in mind that has no fan at all. So what I can definitively say is that my watt meter measurements show the Babyface PSU draws 49.2 watts when running this Xceed kit, the PowerCache, and the spinning platter hard drive. And that's the lowest among the three power supplies, with the SEASONIC coming in at 54.2 watts and the SONY coming in at the highest at 58.7 watts. Usually power draw will directly correlate with heat, so take that as what you will, but for the most part, using a hand touch and all of that, the coolest was either the SEASONIC or the Babyface to the feel of my hand. And honestly, with the measurements that I could get on the thermometer, that's what I could tell as well. In conclusion, the two main problems that I found with the Babyface power supply are, number one, noise on the CRT, especially during cold boot, although I did see it once after running Norton System Info, the benchmarking utility. However, after speaking with Chris, I did find that soldering on a 50 volt 470 microfarad capacitor to the plus 12 volt sweep point at the analog board completely solved the problem. I didn't see the noise happen after that. But even if we ignore the capacitor, Chris did tell me that the 66 to 70 people that he had sold this power supply to at the time, not a single one of them had reported that type of noise problem, including Zigzag Joe, who has a number of power-hungry upgrades, even a Micron Xceed Grayscale kit like mine. So maybe the problem was just exclusive to me, I don't know, but even so, Chris said that he would probably add the 470 microfarad capacitor to a future revision of his power supply. But if you don't have a Micron Xceed Grayscale kit, as my tests showed earlier in this video, you're not going to have the noise problem. The second problem that I found was low voltage. As measured at the external floppy drive connector, I was getting only 4.62 volts, and that's due to the Babyface having the lowest no-load starting voltage out of all of the three power supplies I tested, 5.04 volts. And so you have resistivity losses through the PCB traces and also through the wire harnesses, and that resulted in me measuring only 4.62 volts at the external floppy drive connector, and that's pretty low. Especially because sometimes it dropped down to 4.50 volts, which is very dangerously low, and usually it will result in a perpetual restarting loop of your computer. However, the way to mitigate that is to follow the advice of Zigzag Joe and check the text description below and click the link there, because that will take you to these wires, 16 gauge gold-plated terminals, perfectly sized, pre-crimped, very easy to install, so you can upgrade either your factory harness, your main SE30 wiring harness, or even the Xceed. The Xceed, you only need two the red wires because you can't fit more than 2 in there due to the width of the ferrite bead on there. But you can upgrade your harness and then you won't have any kind of low voltage problem at all. Now there are 3 distinct advantages of the Babyface power supply over the SEASONIC. Number 1, the Babyface power supply is faster and easier to install. Number 2, there is no fan, it's perfectly quiet. And number 3, there is no cutting required in the metal chassis when you install the Babyface power supply, but in the SEASONIC, please check my video for the details, but basically I had to add a screw at the bottom of the power supply in order to secure the SEASONIC inside my SONY metal chassis, and in order to make it fit, I had to cut a hole for that screw to go through. And you don't have to do that with the Babyface, and the Babyface will fit into Aztec or Hitachi or Sony metal chassis, which are all a little bit different, but Chris made it so his power supply will fit into any of them. Now, the distinct disadvantage of the Babyface in comparison with the SEASONIC is price. At today's pricing on eBay, when you factor in the cost of shipping to any mailing address in the United States, the SEASONIC is roughly half the cost of the Babyface. But before you have a knee-jerk reaction to that, you need to consider how valuable your time is, because folks, time is money. And as I said earlier, the Babyface power supply is faster and easier to install, no cutting of the metal chassis at all, plus it has no fan. And I'm personally willing to pay more for a quiet machine because I'm not going to, I used a spinning platter hard drive in this only for a test, but normally I have a Mac SD or I have a Blue SCSI version 2 in there, which makes no sound at all, plus my Noctua fan is very quiet, and having no fan in the power supply really has a lot of meaning for people like me. Your ears, if your ears are sensitive or not, right? So there really is that advantage. Now, after watching this video, if you say to yourself, well, okay, but I'm not going to upgrade my power supply at all, maybe I'll recap it, but that's about it. Still, I would strongly recommend that you upgrade your main harness with these wires because it's so easy to do. And the wires are really not that expensive at all. And especially if you have upgrades, you can really benefit in that your voltages are not going to suddenly drop and cause a freeze or a restart or anything like that. I think every SE30, or even more than the Mac SE, because Mac SEs, you can upgrade them, but usually the beefy, super power hungry upgrades are for the SE30. Definitely you'd want to upgrade your harness. Every SE30 owner should do it now that there's such an easy and convenient way to upgrade your harness. Please consider doing that. And that brings this video to a close. Now it's your turn to let me know what you think down in the comments below. I especially want to hear from you if you have swapped out your power supply with a modern solution. I'd like to hear what your voltages are, especially if you have power hungry upgrades, and what you think overall of a modern solution for your SE or SE30. If you like this video, please consider giving it a thumbs up, and please also consider subscribing and clicking the bell icon if you'd like to receive notifications of future videos. Thank you for watching today, folks, and stay tuned because I have more great content to come. Have a great week. Take care.